everyone, welcome to Human Eye and the Colorful World, which is Science of Class 10. So, in this chapter, we are going to do many things. For those things, it is going to take time. So, for that time, I want your all people's attention, okay? So, when we first come into the first slide, we can see a boy. So, we can see a boy. So he's trying to tell us the eyes. So he's trying to tell us what. He's trying to tell us what is it. The eyes allows us to see. First thing he's telling is that the eyes which he has here are allowing him to see the table. Prescribe and interrupt the world around us through the detection of color and eye. So he's telling that as he can see the table, he can tell that this is black, this is white, this is purple, his shirt color is blue, his hands are skin color, brown pant. Due to the eyes, he is going to tell us. So after that, we can see that there are many things. Among them is a eyeball. This is going to be the eyeball. So we can see that there is vitreous humor over here. So this is a liquid, children, which is liquid. This is a liquid in the eyeball. So all these is going to be vitreous humor, capillary body. So this red color is going to be our capillary body, and we can easily tell that this is a lens. This is a lens. All this. And this is going to be the iris, which will cover the lens. We'll know about these in the further things. This is a cornea, outermost covering. This is scleria. This is not there for you. This is not there for you. Retina. This yellow part over here. This is going to be the optic nerve. These two. And these are going to be the blood vessels. Easy, right? So that is what is being taught us in the parts of the eye. As I told you, vitreous humor means the the transparent gel, like water like structure, liquid like structure, which is present in our eye. Next is ciliary body, which will relax the muscles. So these will relax the muscles, and it will thicken the lens. It will make the lens thick when they are contracting for a closer view. Okay. Next is power of accommodation. So I want you guys to note this down, as we are going to write power of accommodation is going to be the title, and the ability to change the lens focal length is known as power of accommodation. So the ability to change the lens focal length. When we are changing the lens focal length, it is called power of accommodation. When the lens has the ability to change its own focal length, it is called as power of accommodation. Acha, I understood what is power of accommodation. What is lens? So this opening here is called as lens. You can see the brown color eye structure, right? Inside that you can see it. The lens is a clear part that receives the light that enters into the light. So I'm giving some direct light here. It is receiving the light. It received the light. Okay, it will receive the light inside the eye. It bounces off the light to the back of the eye. So it will take in the light. So it will take in the light and it will bounce back to the retina. So this is the retina, children. So it will bounce into the retina to the back of the eye. Next is going to be cornea. So when light enters through a membrane called cornea, it forms a transparent plug on front of the surface of the eyeball. Okay. most of the refraction for the light rays entering the eye occurs at the surface of the cornea. So we thought that this protective layer is called as cornea. So when I send light to the lens directly, first it has to go through this transparent brushed like structure here. It will go through this and then like this into the lens. Any ray that is coming from here, from here, from here, from here, it has to meet the cornea to go inside the lens. So how we have scleria like that also at the back side we have cornea like that we have backside scleria. So it is a white part of the eye. It is made with tough material that protects the inside of the eye. Next is the most important part, which is going to be taken as retina. It receives the light from the lens. When I told you, light will be bounced back to the retina, this part, yellow like structure. So, when it's bounced back from the light, it is made up of rods and cones. So, it is made up of rods and cones, okay? The rods let the eyes sense the light, which helps to identify the color. So, when the light is bounced back, it has rod like structures here. Rod like structures. It is made up of rod like structures which help to identify the color of the object. That is what retina is helpful in. Blood vessels means it will carry the blood to the eyes. Next one is also something we already know. It is the optic nerve. It will transmit impulses or messages from the brain, from the eye to the brain. So next one is eye lens. The eye lens, convex lens. So what lens is being used in the eye lens? It is going to be convex. Convex lens is the eye lens that is used in the eye lens. It will form an inverted image of the object on the retina. Okay, inverted means when you show the area, when you show like this, it will come like this. No, when you show the stick like this, the inverted image will come like this. So, ulta. So, when this bounce back here, it will be like this when the image is actually like this, as I told you. So that is what they're trying to state here. So our next topic will be the near point and the far point. So normally we can see that when we are looking at objects, they'll say, "Mummy, నాకు lens కనిపిస్తలేదు, నాకు board కనిపిస్తలేదు, I can't see the board." All this stuff. So your mother suggests you to have a eye checkup. She'll suggest you to have a checkup to see if your point is up or your point is down. So if you're a newbie, you don't have eye all this specs you don't have. So your mother will suggest you to even still your mother will suggest you to have the eye checkup, children, because when your eye check, like when your sight is like far point, when you can't see further things, it is called as myopia. Okay, so it will not let you to see the far things which are happening, because children, the far things that has its own effect, which I'm going to tell you soon in this chapter only. So when you can't see the further things, it is called as myopia, and when you can see the further things and when you can't see the nearer things, that is going to be called as heteromyopia. I'll tell you some about it in the next upcoming slides. So the near point is the closest distance for the clear vision without strain, usually around 25 centimeters per adult. So you can see 25 centimeters clearly. That is the near point for the adults, young adults. So near point is this much, 25 centimeters. Till here you can see. Far point is the furthest point for clear vision. It is at infinity for adults. This is also for adults and it is at infinity. So defects of vision. Now we are going to know something. Defects of vision. Sometimes the eye gradually loses the power of accommodation when lens get to change its own uh, like when lens get to change its own accommodation, it is known as power of accommodation. Sometimes you lose it. So in such times, people can't see further objects, or some people can't see nearer objects. Okay, that time the vision becomes blurred due to reflective defects of the eye. So that is the reason most of you people will wear specs. Defects of vision and their correction. Cataract. So normally when you see your grandma, grandfather, most of those people till above 40, 45 of age people, they will wear specs. They will mandatory wear specs. They will wear specs due to cataracts, because it is a common eye problem. Cataracts means it's a common eye problem for the age. So you can see this, grandfather here. He's trying to see the phone with the specs. So correction, how to correct that? So, however, cataracts are treatable. These are treatable through surgery, where cloudy lens is replaced with a clear and artificial one. When your parents or grandparents who are uh, above 48 or 45 age, they'll have problems. So the doctor will suggest you go with this surgery. It will fix your eye. So most of them will say, okay, we will do that. Most of them are hesitant to answer, because they don't want early only, they don't want all surgeries and stuff. So some people will say yes, some people will not say yes. It depends on the people. So if you have seen, in many cases, if you have seen, we can see that there are some people who will do surgery, as you can see in the photo. They will do surgery for no further issues. So what do they do in the surgery? They will replace a artificial eye cloudy lens. Means when your eye cloud lens is unable to like take in the rays and all those stuff, they will replace that cloudy lens with a clearer lens. So they said they want to do the surgery. I don't know what's the surgery, but I'll accept to do the surgery. Means it will not be like that. They'll replace it with a artificial and proper lens which can take in light. As I was telling you, myopia, which was nearsightedness. When a person can see nearby objects clearly but cannot see the distance object clearly, the image is formed in front of the retina. So image is formed here. So object is coming here. They can see the near objects clearly, but the distant object will be distant. How to correct this? This can be corrected by using a concave lens to bring the image in front of the, because it is formed for the image is formed front. To bring the image on the retina, we have to use a hypermetropia. So you can't see the nearer things, you can see the farther things. So image is formed behind the retina. In the other case, image is formed in front, not on the retina. So that is what they're trying to tell us. So how to correct this hypermetropia means you have to use a convex lens. So it will increase the uh, glasses. It will let you see big glasses. Persopia. So it will affect people as they age. As I told you, cataract is also a thing. This will affect people as they gain age. For most individuals, they need to use corrective glasses because they can't see further and closer things. Next one is going to be a little interesting and hard one, which is refraction of light through a prism. So I need all your attention. So children here, 1 minute. Erase all my drawings. Yeah. Can you see it? Yeah. Here, children, angle between the lateral faces is known as the angle of prism. What is this angle faces? So we'll take a prism. For example, we'll take this prism over here. I'm drawing it. This prism. So when a ray is sent to the prism, it is known as incident ray. So this incident ray can't go like this straight through the prism. We can take it as virtual. As you can see here, we'll take it as virtual. Okay. So it will bend. Light will of course bend. So it will bend and again it will go. When the light is reflected, it is known as emergent ray, or else reflected ray. Or when the light is going, it is known as incident ray. So reflection of light through a prism. When a light ray enters into a prism from air, okay, when it enters into a prism through air, so it will bend normally. As I told you, it will bend and it will create the surface AC. That everything okay. What is this dispersion of light? I'll tell you. See, when a glass prism can break into white sunlight. I mean, sunlight has many colors, rainbow colors. Vibgor, it is known as Vibgor. So it will happen because each color bends differently. So once red will bend this much long, blue will gray orange will bend this much, yellow will bend this much. So while it coming, it will become small, small, small like this. So red will bend from this, orange will bend from this, yellow will bend here, like that. Bending will be different. So that is what they're trying to tell us in this PPT. Next one is dispersion of light by prism. So you might have seen the aesthetic rainbow, aesthetic what you call it, like this, right? What does this? Why does this rainbow formed? You'll tell sun and rain are together. That wise this will form. No. See, a phenomena is created when the sunlight in the Earth's or atmosphere is reflected and dispersed. So it will occur when the sun enters the water droplets in the air. The water droplets will bend the sunlight. When the sunlight is are entered into in the water droplets, it will bend. They will bend the sunlight over here and then it will create a dispersion. So that is what it means. Okay, we have covered most of the topics. What is atmospheric refraction? See, when objects are appear to waver or flicker when they are seen through a hot rising above air's heat surface, it will happen because the hot air near the source has a different index than the cool air. See, this let us take this as a lake. This is the atmosphere. So this atmosphere will bend into the water. So this has a different reflective index. And even this has a reflective index which is cooler and this will become hotter one. So that is the reason we'll have atmospheric refraction. So our NCRT has many types of things. So what is this twinkling of stars? When stars are appear to be twinkled due to the atmospheric refraction of starlight. So atmospheric refraction we have already learnt in the above slide. So it means that when the starlight has some atmospheric refraction, the atmospheric of starlight appears to be linked. See here, this is a star, some shape it is. Like this it will come, it will go through these all layers and it will come on to the earth. So while it is coming, it will appear to be blinking, children. Okay, your stupid questions will come now. This is also something like that, because to clear your doubts, why do planets don't blink, twinkle? Planets being closer, stars are like millions away, planets are a little bit closer than that. So that is the reason their extended source of light made up many point-sized sources. The collective effect of these all light sources cancels out on variations in light entering into our eye, prevents the planets from not twinkling. Because they are closer, children. They are a bit closer to us than the twinkling of. Some people will ask me, if I go to, I will run towards the sunlight. But why can't I see the sunlight, you'll ask? So advanced sunrise and delayed sunrise. Sun is visible for a few minutes before the actual sunrise, remains visible for a few minutes after the actual sunset due to the atmospheric reflection. So the sun will be so few minutes before the sun is rising into the sky, it will be clearly visible. What shape is it? Everything is visible. When the sunset is happening also, the sun will be visible. We can see the sun with our eyes without blinking our eyes or something. Only a few minutes. So here observer is going to be the earth. The sun is apparently the position of the sun will be this. So horizon. This is a horizon. The atmosphere here will create a effect on the earth. So that is why we can not see the sun when it is like mid noon. We can't see the sun directly. Scattering of light. When the light is scattered, so there is an object here. The object will scatter the light here and there and here and there. The light will come here. The object will scatter the light full. So the even the sun will scatter the light. This is a phenomenon. So that is how we reach the end of our chapter in just 21 minutes. Thank you everyone and hope you have a great day. Bye.